Okay, let's demo the DCA tool with this dataset given to me by the user. So in this case, this is oil rate in cubic meters per day. And this is our DCA tool, which as you can see now, it's empty. Okay, so the first thing we need to do is to paste here where it says the production history. So we're gonna bring this dataset, copy, and we're gonna paste it here. Okay. Now, you can see immediately the charts populated with the historical data. And our first step is to select the fluid, in this case it's oil, and the units. Once you select the oil there, so we had gas, these were in gas rate units. When we switch to oil, this updates automatically, and we need to peak to the metric system for the oil rate. So cubic meters, and the cumulative is going to be calculated off of this rate with this button. And the unit is going to be 1000 cubic meters. Okay, so immediately you can see here this populates, and you have these controls to have a play now. So the initial rate is anchored to the first read, so you can obviously play around with this stuff. Let's leave it there for the sake of this example. You can drag that slider or click on this there. Now, the decline and B factor, so in this case, we had a 0.5-ish factor. Let's, for the sake of this example, let's go all the way to 0. So we have an exponential decline. If it's higher than 0, it's going to switch to hyperbolic. At the value of 1, it's going to go to harmonic. We're moving in decimal terms. That's why sometimes it can be slow if you just click. Whereas if you drag harmonic when it's 1, and let's go back to 0, and the exponential rate di, or initial decline rate, is adjusted so we fit through the data. Now, in a recent version, I added the initial and final rates over which you can do your decline analysis. So for example, if I want to decline over that later period only, there's a bit of a lag. This is just a limitation of using Excel for this. And I just want to use that section of the history, so I adjust I bracket the date range that I want to use. And now let's bring the initial rate down. And again, this is just for demonstration purposes. Let's say I want to use that, okay? And now we're going to the forecast section. The forecast start can be pinned to the latest rate, or you can add a gap to it. Let's say you're gonna have a plant shutdown and are going to reopen some time from now, or you can simply start where the history ends. So that's what that button is. Likewise, with the initial forecast rate, it can be pinned to the latest historical rate, or it can be brought up or down depending on what you know about the field or the well when this is restarted. So you can add that vertical gap, or you can pin it to the latest rate with that button. And the forecast decline rate can be pinned to the initial historical decline rate or the final. When it's exponential, obviously it's the same. There's no rate of change in the decline rate. When it's exponential, it doesn't matter. So we're going to just click any of those. And that initial decline in the forecast is going to be equal to the final decline of the history. Um, Again, for the sake of demonstration, let's go back so you can have more visibility on the history. Let's use the full range. This history is actually very clean, so you can use the full history. And let's use a B higher than 1 so you can see the difference there. So a little bit more decline, but for that big factor. So in forecast, we can pin it to the initial decline. So we're going to start from that rate, but with that initial decline, or we can pin it to the final decline. So it's going to be a little bit flatter. You can see there. So that initial forecast decline can be either that final decline you have in the history or that initial decline. Again, depending on what you think might happen. So if you add, for example, a gap in the forecast and you think to yourself, okay, the field is going to repressurize, it's going to be brought to a new equilibrium, the initial start rate is going to be higher on account of that repressurization. And when I open this again, the initial decline is going to be like the initial decline we had here, something like that. Or you can assume, okay, actually it might be equal to the decline I had at that pressure if this is actually undergoing a repressurization. So it's going to be somewhere in between that one and that one. So you can bring this just dragging to somewhere in the middle of those two. But you have these two buttons to simplify your forecast setup, initial or final decline rates. And the forecast time is the length of this forecast. Okay, so you can go, up to 30 years forecast, or you can go as short as 15 months in this case. Let's say that, okay, nearly 6 years, or let's bring it to 10 years. The years is calculated from the months. Months is the actual granularity that runs in the sheet underneath in the back end that you don't see here, but all the detail and the auxiliary calculations are here. And finally, we have this cutoff rate, which is to cut the tail off. So let's say that, let's add more forecast time so you have enough time to decline to lower values. And let's say, let's add a little bit more steep decline. So let's go back to exponential. And let's add a little bit more decline. And let's say that, just for the sake of seeing this going to very low rates, let's say you want to apply a cutoff of 10 cubic meters a day. It's just to cut that tail off. So see, when I hit this, that tail will be cut off and the forecast time will be reduced to whenever that cutoff is encountered. So right now we have 176 months and we're going to hit that. And that was brought to 96. And you can see there it's cut out there. So let's be more drastic. Let's go to 50. And in this case, it's brought to 44 months of forecast when that 50 limit is reached. Okay, so this is what this cutoff does. If you want to revert and go lower than that, you can just readjust this because this is linked to that cutoff. So if you go longer than that, now this will be brought to lower rates, and then you can reset this cutoff to whatever. This will be readjusted. All these charts update in real time. So in this case, just for the sake of this example once more, let's bring the rate a little bit further up. Now looking at the log chart here, that looks good. Let's leave it as exponential, a little bit less decline. Let's remove the gap in the forecast. So we start from the latest observed rate. Let's start from the latest observed rate at the latest historical time. And let's use that exponential decline rate with a cutoff of 20 cubic meters a day. That's it. That's our forecast. Now we go to the summary and we need to hit this to turn all of that into actual numbers. So there are no formulas here. So this is just to remove any possible error when you copy or paste somewhere else. And let's save this scenario as forecast one, save scenario. After you save, that is copied into the scenario one tab. So now you can go back to the DCA tab and do an alternative interpretation. Let's do one with B of 0.5. Let's add a little bit more decline to that on account of that adjustment. And let's go now to the summary tab, run the summary again, and this is going to be forecast 2. And let's call it b equals 0.5. So you give the name to that scenario you wish. Save scenario. Now you have those two tabs, scenario 1 and scenario 2, and each scenario tells you what exactly was the name you gave or the descriptor to that scenario. So you can be as descriptive as possible when naming the scenario, so for easier uh, recalling of what you meant to do. And here on the left, all the key parameters of the historical fit and the forecast portions you used. Now the master tab is populated. This you need to know your way around a little bit if you want to play with this, but a data model is created from this table the first time around. I tell you there's receiving data. And once it's done, you can create a chart. This is the unit for the x-axis, and this is the unit for the y-axis. Create update chart. So now we have a pivot chart built from the data model we created from this table. So if you click the buttons in the right way, you shouldn't have any problem, as I'm just showing you. So you create the model, you create the chart, and now you can change the axis. So you can display in elapsed time or in dates, and you can display the cumulative or the rate. So let's just change that to date. You see here. Now you can obviously enlarge this. So now you're comparing those two scenarios, scenario 1 and scenario 2. So this is just a tab for you to easily compare all the scenarios you may create from the main DCA tab just by going to the summary and saving scenarios with a different name. So this tab allows you to compare all of those. So let's go back once more for demonstration purposes. Let's now create a um, let's say you want to focus on that portion only, bring the rate down. Let's adjust the B to something higher, just again, just for the sake of demonstration. There, let's use that final decline rate in forecast, and let's go to the summary, run the summary, and let's name this forecast 3 B equals 1.5. Okay, save scenario. So a new tab is created with that scenario 3, that descriptor with all those parameters. Now we go back to the master. We just simply refresh data model. Data model is what powers this pivot chart, which you can use again to quickly compare all the scenarios you have created. And here you can, let's just compare 2 and 3. You can filter those with that filter button there. I mean, this can be embellished further, but this is, again, I threw this out just to get a sense of what the appetite from the users is to continue to build on this tool. So there you go. That's your oil DCA from a user dataset. Cheers.